Hey, welcome to the notes for 6.2 AP Calculus. This is the part 1 video. So in this video, we're going to take a look at integrating exponential functions. So there's a little exploration. I suggest you guys pause the video, give it a shot, see what you come up with on your own. All right, so if we were going to go through and do this, we want to find each derivative and then we want to use the result to evaluate the integral. So if we looked at that, we can go ahead and just take the derivative of e to the x, which hopefully we remember is simply e to the x. All right, e to the x is one of the unique functions in that its derivative is the function itself. Now, if we were going to do the same thing for part B, you want to always make sure you recognize that there's an inner function here, so we're thinking chain rule. But anytime you take the derivative of e, you're going to start with the function. So we got e to the negative x squared. And then we're going to go ahead and multiply by the derivative of that inner function, which is negative x squared. And that derivative is going to be negative 2x. So typically you're going to go ahead and see that rearranged. So y prime is going to be negative 2x e to the negative x squared. And that is how that's going to work. Now from there, we can kind of use that idea to take the integral of those functions as well. So if we want to take the integral of e to the x, well, you've got to remember that the integral is the opposite of taking a derivative. So basically, we're going to go this way, right? So e to the x is the derivative of e to the x. Therefore, the integral of e to the x is simply e to the x plus c. And if we were to take a look at d, we've got negative 2x e to the negative x squared. So we want to remember there is no product rule, there's no chain rule for integration. So most likely this is going to involve u substitution. So if we were going to go ahead and let u equal negative x squared, then du is negative 2x dx, which basically is what we have. You could rewrite this as the integral of e to the u du. So the derivative would be e to the u plus c, which if we were to substitute back in, we get e to the negative x squared plus c, which is what we would expect because negative 2x e to the negative x squared was the derivative of e to the negative x squared. So that whole idea of working backwards. All right, so now that basically gives us the rule for integration with exponential functions that have the base e. The integral of e to the u du is simply going to be e to the u plus c. So when we want to take the integral of functions involving e to a power, we want to get it in the form of e to the u. All right, so again, just think u substitution. Guys, pause the video, try to take this integral on your own. So we've got the integral from the integral of negative 2x cubed e to the negative x to the fourth. So again, no product rule, no chain rule. We're going to use u substitution. Let's let u equal negative x to the fourth. That means that du is negative 4x cubed dx. All right. Now, again, those of you guys that are in my class know, I always like to make sure that whatever's here is what shows up over here. So we want negative 2x cubed dx. So what I'm going to do is in order to make this a negative 2, we're going to divide by 2. So that means that 1/2 du is negative 2x cubed dx. And that's at that point, I'm going to be ready to substitute. So we're going to get 1/2 the integral. The negative 2x cubed dx will get replaced with the 1/2 and the du. And then the negative x to the fourth gets replaced with u. So this is simply e to the u du. At that point, pretty easy to take the integral of that. It's 1/2 e to the u plus c. Because this is an indefinite integral, we should plug back into the original variable, giving us 1/2 e to the negative x to the fourth plus c. And that's how we can integrate using an exponential with base e. All right, let's go ahead and take a look at the next example. Okay, so in this example, we've got the integral of e to the 2x over 1 plus e to the 2x. So, things you want to think about is no quotient rule. So, most likely we're going to use some form of u substitution. So, pause the video, try what you think you would do in this problem, and then we'll take a look together. So as I look at this, I've got e to the 2x on top. I've got 1 plus e to the 2x on the bottom. I'm going to let u equal 1 plus e to the 2x. Because there's no way that I'm going to be able to get rid of that 1 if I let u equal e to the 2x. But if I let u equal 1 plus e to the 2x, du is simply e to the 2x times 2 dx. So at that point, again, we don't have 2e to the 2x, we just have e to the 2x. So let's get that 2 over. 1/2 du is e to the 2x dx. As we go and start to substitute, we're going to have 1/2 times the integral. All right, e to the 2x is getting replaced with du. So this becomes 1 over and then du. Well, the 1 plus e to the 2x is u. So now we have 1 over u. All right, now you got to think back to what we talked about in the previous class. How do we take the integral of 1 over u? Well, this is going to be 1/2 the natural log of the absolute value of u, and then plus c. We're going to go ahead at that point and replace u. So we have 1/2 ln of the absolute value of 1 plus e to the 2x plus c. And then the question you got to basically ask yourself is, are those absolute value bars necessary? In this case, 1 plus e to the 2x is always positive, which means they're not necessary. So we can get away, or we don't, no, we can't get away. We want to remove the absolute value and call it 1 plus e to the 2x plus c. So if that value inside of the absolute value is always positive, then the absolute values are not necessary and we need to remove them from our final answer. All right. All right, guys, let's take a look at example 3. So now when we look at example 3, we have 2e to the x minus 2e to the negative x over e to the x plus e to the negative x quantity squared. So we need to try to figure out what to make u. We've got a quotient, we've got a value taken to a power. Let the inner function be u. So we're going to go ahead and let u equal e to the x plus e to the negative x. As we take the derivative of that, du is e to the x, and this plus e to the negative x will become negative e to the negative x. So this will become minus e to the negative x dx. Now, if you look at the problem, we don't have e to the x minus e to the negative x, but we do have 2 e to the x minus 2 e to the negative x. which we can get if we multiply both sides by 2. So 2 du is going to be 2e to the x minus 2e to the negative x dx. At that point, I'm ready to substitute. So I'm going to put the 2 in front. We're replacing the 2e to the x minus 2e to the negative x and the dx with the 2 du, because there it is. So on the bottom, we've got e to the x plus e to the negative x, which we're replacing with u. So this is going to be 1 over u squared du. Now, what you got to be careful of is 1 over u squared, when you integrate, does not give you the natural log of the absolute value of u. All right, this is going to be done with the power rule. So we're going to go ahead and rewrite it as u to the negative 2 du. And then as we integrate, we've got 2. All right, we're going to increase the power by 1, so this becomes negative 1. Multiply by the reciprocal, so negative 1. And then you've got plus c. So we can kind of, in a way, look at this as negative 2 over u. And u was e to the x plus e to the negative x. So let's go ahead and rewrite that as negative 2 over e to the x plus e to the negative x plus c. And there's our integral. All right, guys, one thing I forgot to write up here was that I'm going to just add in there before I finish the notes, but that quantity is always positive. And because of that, we don't need the absolute value anymore. We said it, I just didn't write it on there. I figured I'd add it. All right, guys, that's going to do it for part 1 of the 6.2 notes. Make sure you check out part 2.